simple. So let's get back to the plane. Okay. From YZ plane, how much? 5 mm above we have to be. Okay. Create a plane here. Say plane. So plane here. This is a plane. How much offset? It's 5 mm only as per the drawing. It's 5 mm. Okay. A. So the geometrical set. Usually it should be the geometrical set. Okay. Let's say 0. Okay, this should be okay. Let this be inside this. Now this is my plane. Okay. Consider it position sketch. So what is the orientation we want? Let's consider this orientation. Okay. So this is vertical and this is horizontal, right? So I need the same orientation. So let's work on this. Okay. Okay. Now these lines are exactly tangential to this circle and this circle. Very simple. Okay. Let's extract. Okay. One and that. Okay. So let's isolate it. This also. Okay. Now, yes. Okay. Now these lines that we let's constrain it first. Okay. And with the point here, exactly possible. And let's convert this to constructional point. Okay. Again, this must be concentric to concentric. Okay. So this is constraint, and we need axis here, this here, and this one. This must be coincidence. Coincidence. Okay. Done. So this already we already created this. Okay. In previous stage. That's why I have not explained you, but hope you understand, right? So I have created two circles and just constrain it. Okay. Any questions on this? Any doubts in this? What we did, we selected the face. Okay, we selected the first we created the plane as per the drawing. In drawing it is given clearly at what height the rib is created. So at the same height we have created, that means 5 mm from the surface, bottom surface, 5 mm we have considered, and then on the same plane we consider these two circles here. Okay, constructed. Now we are going to take two lines here. create the rig, okay, and this line is tangential to this, okay. This is tangency, okay, and the same line is tangential to the big circle also, tangency. Now this is normal view, okay. If your view is like this at an angle, okay, if it is not clear to you, then you can click on this normal view so that you can get this normal view. Okay, now what is required for me? Simply I'm interested in this profile, this and one more line here, okay. So let's create a line, okay. So now we need this profile, okay, completely this profile. Okay. Now what is not required, how to do that, cut, cut, done here, okay. Again here, cut, completely done, okay. Now what is required? If we are missing anything, then immediately we have to. So we want this, make sure these are again tangential to this, tangential, okay. This line is also tangential, tangential. Now both the lines are tangential. Now if you cut it, this will take up to here. Okay. Now I need to use this trim option to close this profile. Okay. Close the profile, click on this line, and this will be closed here. You get it. Now this is closed. Okay. And again, see here, the line is not closed. Okay. The line is stopped somewhere here, but it should be closed. Okay. It should be tangential to this circle. Click on the circle, and it will be closed. Okay. And see here, to be on safer side, always check and click this, okay. Use this trim option so that you can close all the circles and the lines, okay. Even this I'm again closing, okay. Okay, now let's check our so how is the sketch now? All good, okay. Closed, it is closed. Let us just close. Okay. Let's come out of this. Let's try this pack. Current work object is now. What is the thickness of this? This is around 12 mm. That's what we want. Okay. 12 mm. Okay. Save it. So any doubts or questions in creating this, right from the creation of plane, considering the orientation and creating a sketch, and then applying the path. Any question on this? All good? You're with me, right? Okay. Great. Next, let's see what is the next step for us. Okay. This next first step for us. Final feature which is left over is this label. Okay. The top label. So now again, tell me where to take the plane. Okay, which plane I have to consider, and how to create this label. Okay, so we have to create a sketch. So on which plane we have to create the sketch, and where exactly we need to take any dimension required for this, or in which view it is given. Definitely in this view I don't see anything. Okay, so maybe here you can find something. So have a look at this. Okay, this will give you good idea of that. Okay, so which is the view, this view, where to create that and how to generate that. Okay, take 1 minute and give me answers. Okay. So guys, clear on this? I'm looking for answers. So which plane we need to select? Which view? Front view, top view, side view. Which is good planes right now?
So it's jet explain.
ZX. Let's have a look at here. ZX plane is nothing but our side view. Okay. Right hand side view. Okay. This view is okay. Okay.
Yes.
Side view is okay to create this. Okay. Good. And where can we? Do we need to generate a separate plane for this? We need to generate a separate plane? No, because
No, sir.
we have already a plane which is exactly at the center. This is exactly at the center, so we can make use of the same plane. Okay, so okay, let's select this ZX plane and this. Okay, so we need to avoid all unwanted operations, we can say, okay, using unwanted commands, because that will increase the file size. We are going to increase the file size. Okay. Instead of increasing, of course, if it is required very much, then only we have to do it, or else let's not increase the file size. Okay, so as per drawing, what they are saying, rip starts from this face to this face. Okay, and it covers completely. Okay. So let's consider this face to this face. What to do now? Next step would be just extract this. Okay. We have one. If it is circular, like this kind of cylindrical shape, then you, this is the option. Okay, remember this. Project 3D Shillahawk edges. Okay, this is the option which will help you to project. The normal this thing, if it is a pad or kind of thing, okay, on the top surface you can project. But if it is a circular, cylindrical, if it is cylindrical, then this is the option. This is okay. You can see the cylindrical shape here. Okay, and this is known as project 3D Shillahawk edges. Remember this. This is your interview question. Okay, they are going to ask you that. Okay, now select this and select. Now lines are selected. Again, select this. Selected. Okay. So look at this selection onto the sketch plane failed. Selecting surface cannot be projected. Why? This is projected and this is not projected. Friends, Catia. Okay. Yes. Let's consider the distance. What is the distance from here to here? Then we'll consider the distance and then have a line. Let's consider a line. What is the from this center to this center? It is from here to here. This 149. 140. Let's track. Let's constrain this line first. Constrain it. 30 mm. And this is my construction line. Okay, I need this construct. So this is my construction line, and one more construction line which I need here is center to center again. Check this 100 mm, and this is this is 38. Okay, now center to center. Yes. This is actually 100. Okay, now offset is 8. Okay, that's my construction. Okay. Now this is my point. It's actually the top point of this face, and what is the top point of this? Yeah, so let's isolate it. Just for our reference, let me just put it. So constrain it. Okay, from here to the top point. This point I want. Okay? This point. Now solid line. Okay, this I don't need. Okay, now let's close this profile. Let's consider this as solid, and this is solid. Again, close. Okay, and this one simply select here. This also should be isolated. And on this, say, profile is closed. Okay. Now let us constrain it. How to constrain? Okay. It's horizontal. Take one dimension from here. Let's constrain. Now we need to. This is at an angle, right? So we need to give angle. Okay, and then this point is constrained, and how about this point? Height of this should be constrained. Then let's check. Once which is okay, closed, and all good. Okay, now come out of this. What is the thickness? It was 12 mm if I remember. Okay, the thickness of the rib is 12 mm, so we can consider the same thing for this. Is there any other dimension related to rib? There is no other dimension. Okay, it's clearly visible here, but there is no other dimension mentioned anywhere. So you have to consider the 12 mm rib. Okay, now what is so it should be from 12 mm, must be distributed from the center. Okay, so we have to give 6 so that it should be equally distributed on both sides. Okay, both sides. Okay, okay, get this. We have to use let's use rib option here. That rib option should be used, then only it will be closed completely. Let's delete it. This, this, this. Let's okay, from top. Okay. Can use yeah. No, it's not taken. Usually we have to use open profile. Okay, it is giving some method. Let's follow another method or else. So, here from the top, this method. This is the best method actually. Okay, as of now, let me just tell you, and I'll find out this problem and then resolve it. Okay, so this rib operation, I'll check and I'll let you know. Okay, it's taking some issue with the sketch it seems. Maybe we need to modify the sketch. Okay, yes. Okay, so any other questions for on this, please? The rib one, I'll check the sketch and I'll update you in next class. Okay, the what error it is giving and how we have to resolve it. Okay. Other than that, any other questions on this? So apart from this, we have few more operations. We'll have a look at operations also. Okay, few we are already using. You are aware of that. Okay, so these mirror parts, symmetry parts, we use this. Mirror, okay, and I'll show you how to use these options like creating. Okay, guys, any other questions on this? Please try to practice this part. Okay, take a pic of this, or you can take a screen grab of this and try to practice this. Only other than the rib end portion that I'll check, and I need to check the sketch. Okay, and then I'll update you. Remaining everything, I think you are clear on this, right? Any questions on this, please? Oh, save it. Okay, so this is again a machining part. Okay, so we did usually we'll be having so many machining parts. That's the reason we are working on these machining parts. Apart from this, we have sheet metal parts also. So initially I showed you how to construct a sheet metal part. Okay, let me show you. We have one option which is very useful for sheet metal parts in this. Remember this one. Okay, shell definition. Okay, what is shell? So let us see how to use this. Okay, I'm closing this. Okay, so please try to practice this and then come back with your questions so that we can see this portion. Either we also can do this from the top portion also. Okay, if you are using this thing, the pad definition. Okay, you can take profile like this and extrude, and then from side view you can cut this. Okay, like that also you can achieve it. You try to get this. Okay, meanwhile I'll find a simple solution for this also. Okay, that is we can say that is two steps extra we have to do if you have to achieve it from the top. Okay, top view. From side view we can use pad, uh, but to achieve it properly wrapped we need to use the stiffener. Okay, so the stiffener also I'll let you know in next class. Okay, as of now you try to achieve it from the top. Okay, from top view you can take this face. Okay, so create a plane on this face and then generate this profile, generate this profile as per this, generate as per this is nothing but 12 mm thickness, and it is tangential. This rib is tangential to this, and then you can achieve it. Try. Okay, try. When you play with this, then you can get a lot of things. Okay, just don't try just what I'm teaching you. Apart from that, you have to play with that. Okay, get into this. There are so many options. Try this one, this pad, if not this one, and just try this. this thing. Okay, we use this today. So you saw how we have used that. Okay. Okay. So any other questions in this? If it is okay, then I'll close this and then we'll see some more options today. New options. Okay, guys. Right. Okay. So mostly we worked on these machining parts. Okay. What if it is a sheet metal part? Okay. Kind of bending parts. Okay. Simple bending parts. So how to achieve them? Okay. For example, see, I've considered the front view. Okay. Let me do this. Let's take this. Okay. Take this thing, something like this. Okay, this only will work out. Okay. And simply this and this must be this and this symmetrical. Okay. And this. Let's constrain this. Constrain this. Okay. This. Let's say this is a finally. Okay, if you come out, use this flag. Okay. Option. Say 50 mm or say 100. Okay. See, this is usually what is the operations done on sheet metal part. Okay, a sheet metal part is mostly bending is done, right? Bending, forming, all these operations are done on to achieve the desirable shape of the sheet metal. So how to achieve that? Okay, so first you need to give radius, maybe more than this. Let's say 30 radius. Okay. Okay. And then I need something here, say at this portion, I need to have a dent here. Okay, so how to do that? Maybe let's simple dent. Okay, so I'm going to remove the material. Okay, so let's transfer this plane. Okay, this is back. Okay, something like this. The round circle. Okay, so there we go. Material. Okay. Okay. So how to get this? Yeah. So now shell operation. Okay. Before going to shell operation, again we have removed the material. That means this is a dent kind of thing here. So definitely, what is expected here? Again, you can expect this. You cannot expect this sharp edges. Okay, so it's going to fail again. It's going to fail. That's the reason we have to provide edge fillets. Okay, edge fillet of 30%. Done. Now also I need these edges to be say 30. Let's decrease the say 10. Okay, so and I want a sheet like I want only this much bracket. Okay, that case let's I'm going to remove some this one. Again, no sharp edges here and here. So now final operation is shell operation. Okay, to achieve shape of this. Say this is 2 mm thickness. Okay, what is the default thickness is you have to define the thickness here. Okay, and select the faces where this material should be. Okay, these are the faces. This is the outer surface. Okay, complete outer surface. These are the outer surface, so you should not select this outer surface. You have to select the surface where you need to. This will be your final part. to have a look at this. How you fix it. This is kind of what is the thickness of this? You can check the thickness. We have given 2 mm thickness. 2 mm thickness. And this profile, what we created here, okay. This is how these profiles are created, okay. And if I want to have a hole on this, okay, let's select, want to hole, maybe on this surface, okay, directly go here, okay, a hole here, a hole here. I'm not giving dimensions, I'm just showing. So now we have most of the parts we did on machining parts, okay. What we modeled are machining parts, the process we followed for machining parts. If it is a sheet metal kind of part, okay, then we have to follow this kind of process. Okay. So you have to create a pad, and some operations you have to finish beforehand before applying. Even these holes also you can finish beforehand. Okay. So this you can reorder. Maybe after this, if I say, then let us see. These holes also you can finish it. Okay. These holes also finished, and now when you select, you have to select this face also, this face also, this face. Okay. If I define it, this is the problem. Okay. But when you select it, face also, this face as well as this face. That. Okay. Remember this command shell, very useful command to create such kind of sheet metal parts. Okay. Any questions on this, please? I'll find sheet metal drawings. Okay, we'll work on sheet metal drawings also. Okay. I'll get you some parts which are of sheet metal, and we'll try to model some sheet metal also, so that you can get a different manufacturing methodology idea, how this can be manufactured. Okay, how, and in Catia how we have to follow the methodology for sheet metal also. Okay, that I'll tell you. Okay, guys. So, any other questions or any information to share? So, till now, we have done around 8 to 9 parts or 8 to 10 parts we have completed, and hope you got them and you practice them. Okay. So, please keep practicing, and let me know your questions. I'm not getting any questions from you guys. Okay. So, I hope everything is fine. Okay. I hope everything is fine with you. You are getting everything and you are practicing well, and there are no hurdles in creating this idea models. Okay, hope you people are able to finish them. That is what I'm expecting, because I'm not receiving any questions or queries from your side. So that's the reason I'm assuming that you people are doing it fine. Okay. Uh, and if you have any questions or any doubts on this, or you can contact me. Okay. You can send me messages. Okay. In WhatsApp or in the group. I'm in the group, so you can send me messages and we can discuss over that. Okay. Any other information, guys? Any other questions? Next class, let's. I'll find some sheet metal parts for you, so that we can practice sheet metal methodology also. Okay, that we will start practicing now. I'll find some parts. Okay, and if you have any questions, or if you come across some interesting model, okay, and if you are practicing it, then share it with the group also, so that your friends also can see that if it's a different one, and you're learning something. Okay, then you can share that also. Okay, fine, guys, all good. Okay, if everything is good, okay, then please practice that. And the other things I'll see in next class, we'll see sheet metal parts. Okay, I'll find some sheet metal parts that I'll search. And apart from that, if you have any questions in previous models, please go through and let me know. Okay, and also we'll have some few classes on seating systems also. We started seating systems, and I um, have covered some important information which is required for you. And also we have a few more slides left over, in which information which is important for you, so that also